I would like to thank you all for coming. It's amazing how many people just showed up. So I guess everybody is interested in running MySQL on Kubernetes.
Sami, it's not possible to hear you from here.
That is unfortunate. Does this help? I can try a bit louder, but I'm not a very loud person. Good. Or does this
the
thing?
microphone is just for the recording.
Okay. So I just have to try yelling at you.
Yes.
Great. Where was I? I want to talk about running MySQL on Kubernetes. And just before we get to that, my name is Sami Alros. I work at Percona as a support engineer. Been doing that since last April. Would you mind not leaning on the light switch? It's kind of confusing me. I have been working with all sorts of open source technologies since, well, almost all of my career, since 1995 or so. I got in touch with MySQL for the first time pretty much when it became available, around 96, 97. And yeah, I think that's enough about me. We want to talk about something more interesting. What we are going to cover is what would be the point of putting MySQL on Kubernetes? And how would we get started doing that? And as a support engineer, I just find backups and restoring super interesting. So I want to talk to you about that. And scaling a database up and down while it's running, how that would work when running MySQL on Kubernetes.
And don't forget to yell at Lisbeth.
To yell even more?
Yeah, it's possible, if possible.
Oh,
think
that's
it's better
bad.
over there.
Don't be shy.
Yeah, but I am. And I'm just a quiet person, sorry about that. Maybe come closer if you can't hear me. And finally, I want to talk a bit about monitoring my MySQL in Kubernetes. So actually, before explaining what I think is the point, I would like to ask, who of you is using Kubernetes? I don't mean for running database, but for running anything at all, like applications or other stuff. Yeah, maybe roughly half-ish. And a follow-up question, who is actually using Kubernetes for running databases? See, about 5-ish hands. Good. It's, to be honest, it's what I expected. So the point, in my opinion, is, like we just saw, a lot of you are using Kubernetes for running your applications, but not putting your databases in there. But it could make sense to run your database on the same infrastructure, on the same stack as the application. Deploy both together, keep it simple, and it can be simple. Like, I guess the ones who did not raise their hand a moment ago have their databases on dedicated machines or on dedicated virtual machines. And those need their special care and feeding. And yeah, maybe we can make it simpler by putting both in one place. Kubernetes is really good at resource allocation. Like, you can configure limits on this database may use 1.3 CPUs and 1 GB of RAM or whatever. You can also configure guarantees. This database will always get at least 4 CPU, and you can configure burst limits, which, yeah, don't want to get too much into details about what Kubernetes can do, but those would be, how do you say, yeah, good things to have, could make management more, yeah, creative, interesting. And another cool thing about Kubernetes is affinity, anti-affinity. Say you have a database cluster, you don't ever want 2 database cluster nodes on one physical hardware. you can tell Kubernetes, make sure these two pods never run on the same server. Or since we will be, I'm spoiling here, we will be using Cholera replication here, you could configure Kubernetes to keep all nodes of a cluster in one availability zone to keep Cholera happy, but still on separate hardware. You can do all that in Kubernetes. So yeah, lots of possibilities there. And Kubernetes is really good at scaling things up and down. I will show you in a bit. And there is even an auto-scaling in Kubernetes. Try it out before using it on your database, but it is possible. And finally, automation. That's kind of what Kubernetes was made for, orchestrating, automating your things. And we can actually use that for our databases. Actually, one more question. Who thinks Kubernetes is complicated? No, again, maybe half or almost half. There is a learning curve, I admit. I'm far from an expert, but you can actually get used to it pretty quickly and it starts to make sense at some point. I promise. And actually, I'm going to say running MySQL on Kubernetes can be surprisingly easy. You will see. So, getting started. How would we go about getting started? Well, as I spoke with one of you earlier, you can start some pods in Kubernetes and write some scripts for setting up replication, and it may work. But it can also be pretty complex, and it's not fun. And I have done this, and you have done this, and yeah. But there is a piece of software that can make it fun, a lot more fun. And that is called the Percona Kubernetes operator for Percona XtraDB cluster. Now try saying that quickly. Since I absolutely cannot say that quickly, I'm just going to call it the operator. And if I'm talking about the Percona XtraDB cluster, then I'm just going to say PXC. Anything else is, yeah, taking too long. We only have 20 minutes after all. So yeah, the operator is free, open source, and you can clone it from GitHub and get going. Easy. What is an operator? Just very shortly, with an operator, you can basically extend Kubernetes. You can define the so-called custom resources, and in our example, a database is a custom resource or a cluster of databases. And so the operator deploys Percona XtraDB clusters, like I said. PXC, I think most of you have heard of PXC, so I'm not actually getting into too much detail there, but more free and open source. I obviously would not talk about anything else at FOSDEM. With the Percona operator, you get Percona server for MySQL 5.7. There is no 8.0 yet. We are working on it. There will be one at some point, but I cannot tell you when. And yeah, requirements for running MySQL on Kubernetes. A Kubernetes cluster is required. Can be Google Kubernetes Engine, can be OpenShift, works fine too. There are some version constraints which I did not write down, but you will find them in the documentation. Or if you just want to try this out, you can get it up and running in Minikube. And if you have Minikube set up, I promise you can have your database running in less than half an hour in Kubernetes. So yeah, I think I mentioned that. You can get the operator from GitHub, you clone it, you deploy a couple of files, and you will have your first database running in Kubernetes. Is this readable at all? I guess in the front row maybe. I hope. I was going to do this live, but somebody told me to not rely on the internet here, and turns out my old laptop doesn't handle lots of Kubernetes clusters not very well. So we get screenshots today. I guess I could have selected better colors. Sorry about that. It looked fine on my screen. The thing with Kubernetes is kubectl. Kubernetes control is what you use to control things. We apply the so-called bundle YAML, which came with from the GitHub repository we cloned, and we apply two YAML files, like I mentioned, bundle YAML and CR YAML. CR stands for custom resource, and that file looks terrible on this screen. I promise next time I will make black on white. The thing is, you can define name for your cluster, size for your cluster. Oh, which reminds me, the slides are, of course, in the FOSDEM program, so you can download them there and look at them on your phone. So that might help, might make these more readable. Define the size of your cluster, how much memory your nodes are getting, limits for those, what kind of disk, SSD disk here, with size of 6 gigabytes. You can define a lot of things in the cr.yaml. This is just a small sample of that. You apply that after modifying it, and you wait a bit, and you do kubectl get pods to see what's running. So the operator went and started 3 proxy SQL pods for us, because that's what I configured, and 3 PXE pods. And the cluster operator itself is running. Actually, I see the last proxy SQL pod is still pending, but it will be started at some point. So that's how easy it was to have proxy SQL and Percona server PXE running in Kubernetes. Deploy 2 files, assuming you have a working cluster. The operator also sets up a few Kubernetes services. I guess for people who have not had exposure to Kubernetes, a service doesn't mean a lot. But what you need to know is we have our cluster 1, which is what I named my cluster, proxy SQL. It has an IP. I can point my applications at that service, and my application will actually work, assuming it's running in the same Kubernetes cluster, can reach the service. Just to demonstrate that it works, which I guess you cannot see very well, I started a MySQL client inside the cluster, pointed it at the cluster 1 proxy SQL, created a database and table, and it just works. Proxy SQL does its magic, sends my connection to where it belongs, and I have MySQL in Kubernetes. Looks simple, doesn't it? Or does somebody not agree? Everybody agrees. Fantastic. So I told you. I promised to talk about backups because I find backups interesting. So the operator actually offers us a way to take backups. You get 2 backup destinations out of the box. You can send your backups to an S3 compatible storage, or you can use a Kubernetes persistent volume. You just, in the CR, custom resource YAML, you can define a, that looks much nicer than the previous screenshots. Just define a schedule, like a cron job. Tell it what should be backed up, where should the backups go. Easy. And if you happen to think of taking a backup on demand, just apply a file like this to the operator. It says go and create a backup called backup1 from cluster 1, store it on my Kubernetes persistent volume. Apply that and wait a bit and run kubectl get pxc backups, and we will see my backup has been created. Took 13 minutes, is 6 hours old, whatever. Backups happen, yeah, super easily. So how do we restore a backup? Almost as easy. When we cloned the repository, we got a script called copybackup.sh. I think what that does is pretty obvious. We tell it which backup we want. Backup 1 is from that get pxc backups output. We tell it where to put the backup, and we wait a bit, and we have a local copy of the backup, and the script actually tells me which commands to run to start a local instance with that backup. So I can do whatever I want with my backup, like verify it's healthy, use it for whatever you do with backups. Yeah, scaling up, scaling down is what I promised to tell you about. Scaling up a database cluster is traditionally not always trivial. I mean, it can be if you have proper tooling. And with Kubernetes, you basically have the proper tooling right there in your hands. So like we started earlier, our cluster with 3 proxy SQL nodes, 3 PXE nodes. My backups are there as well. Let's ignore those. I go and edit the custom resource YAML file, set the cluster size from 3 to 5, apply this file, wait a moment, and I have my PXE nodes from 0 to 4 up and running. Scaling a database cluster up in Kubernetes is that difficult. Okay, behind the scenes there might be a few more details, but in a simple case, that is how it works. And well, scaling down, I think no big surprise. Go back to the YAML file, change the cluster size, apply the file, and we see Kubernetes has already terminated my PXE4 node. It's terminating PXE3 now. So the cluster will be 3 nodes again. Thanks. And we have 5 minutes time, which is perfect because I only have one more topic left to briefly explain about. How would we go and monitor our database, our PXE cluster running in Kubernetes? We could use Persona Monitoring and Management, or PMM for short. Another, free open source piece of software. It's built on Grafana, Prometheus, ClickHouse. You can use it to monitor not only MySQL, or Persona Server, MariaDB, but also MongoDB, Postgres. It's a pretty flexible piece of software. And you can even install it inside your Kubernetes cluster. I mean, like we just established, running everything inside Kubernetes could make sense. You get a so-called Helm chart. I will have a link for you. The Helm chart, Helm is a package manager for Kubernetes, for those who don't know. It's literally 2 commands to install the package inside your Kubernetes. And you do just, Helm install PMM server and a couple of parameters. And that will actually work most of the time. And to enable monitoring on the database nodes, you go back to the custom resource YAML, set PMM enabled, and you will have the PMM client running in a sidecar on all your PXE and proxy SQL nodes, and you will have monitoring set up that easily. And just a screenshot of how PMM could look like after it's been running for a while on my PXE cluster. PXE is a very powerful piece of monitoring software, but we are not going to get into that. That would be like a talk or three of its own. I think there might have been one today. But that is actually all I wanted to tell you about running MySQL on Kubernetes. How are we time-wise?
We still have 2 minutes and then still 5 for questions.
Perfect. So like I said, the slides have all the interesting links. Well, I find them interesting. I hope you find them interesting. And yeah, with that, any questions? Sir, in the front.
Do you have any problems with preemption of your MySQL pods?
You're going to have problems with that. Do I have any problems with preemption of my MySQL pods, which can turn into a problem indeed? Yes. It's again about resource allocation.
Do you have any tips, or how do you solve it, or what's your way to solve it?
I do not have a way for you to solve it off the top of my head. We'll be happy to talk to you about this later on, because I would need to think on this a bit. Sorry.
Sure.
So next question, I think I saw the gentleman over there.
Are you using any persistent volumes for the cluster members?
So,
If not, how do you deal with large databases that they string into web?
so basically two questions. Would I use, yeah, so would I use persistent volumes for datasets? Generally, yes. And the next question, how do I deal with large datasets? Well, with running your stuff in Kubernetes, a large database can get clumsy. Like, say, it's Galera. So a new node joins, it does a full SST, and if you have terabytes and petabytes, it can take pretty long. Bring patience, or bring smaller databases. So yeah, sharding, for example, will work. Yeah, back there.
So does the operator have any support, or if not, do you have any advice on how to run databases that would be the same replication chain or the same cluster across different Kubernetes, which are potentially spread?
I'm sorry, I'm having trouble hearing you.
Yeah, so does the operator have any support, or if not, do you have any advice on how to run databases that you need to spread across multiple Kubernetes clusters, potentially geographically apart?
Okay, so how would the operator handle running a database cluster spread across multiple Kubernetes clusters, possibly geographically spread? The operator does not handle that for you at all.
Do you have any advice on that?
Not off the top of my head. No. Yeah.
First time I spoke about MySQL, I heard about a tool called Vitesse. I don't know if you are aware of this, and if so, what are the benefits of using this tool versus the other one?
So what would be the benefit of running Percona
Versus Vitesse.
Percona operator or Vitesse? I feel like I'm saying I don't know a lot, but I don't know enough about Vitesse to compare. Yeah.
There is a Helm chart on MySQL hireability. So how this is different? Like how is better?
How this is? I haven't compared the two.
You invented the wheel if it's already there.
I only have used the Percona operator, and I know it works pretty nicely. I haven't had a chance to work on the other one.
How does Kubernetes impact the latency and big data of the database?
So how does running on Kubernetes affect latency of database? It depends. It depends a lot. I mean, if you have your nothing else running on your Kubernetes nodes, Kubernetes itself doesn't do much there, right? I mean, it's Docker containers, they are pretty lightweight, so a few percent maybe, but try it out with your workload to know for sure. And tell me if you test it. I think I saw a question here.
Yeah. Did you have a chance to run some benchmarks on MySQL running on Kubernetes in this mode versus normal VM style or even bare metal mode?
So did I do benchmarking of MySQL on Kubernetes versus bare metal? I have not done such benchmarking. I mean, there will be an overhead. I don't think I have heard of such benchmarking either. I mean, it also depends a lot on what's going on in your cluster. So it's a very open-ended question, really. Try it out. Sorry?
Expectations.
Uh,
5%, 60%.
Well, Kubernetes itself adds barely any load. Docker does add some, so I'm going to go with 5 to 10%, but please don't take it to the bank.
We are done.
We are done. Thank you, everyone.